All right, so this is the lecture for November 8th. We're looking at a very simple concept today in comparison to what we were looking at last time. Today we're going to be looking at types of chemical reactions. And the best part about this is that there's only 4. We have synthesis, decomposition, single replacement, and then last but not least, we will have double replacement. These are our 4 different types of chemical reactions. First, when we have a synthesis reaction, this is when you have 2 or more compounds or elements forming one singular compound. This would be like hydrogen and oxygen coming together to form water, H2O. If I'm going to use my cubes, I would have water and oxygen coming together to form H2O. So 2 reactants coming together to form one singular product. That would be an example of synthesis. Decomposition, on the other hand, is the exact opposite. When you have a singular compound being broken down to its basic parts. So again, we can use water as our example. It is being broken down into both hydrogen and oxygen. That would be an example of decomposition. Singular compound being broken down into its basic components, hydrogen gas and oxygen gas. So anything that is breaking down would be an example of decomposition. Single replacement is when one element/compound switches its partner. And we're putting partner into our, quotation marks, mainly because your partner is dealing mainly with its charges. And so we're looking at positive and positive and negative and negative. So if I have, here's a negative, and that's actually another negative. We're looking for a positive. Well, that's okay. We can draw more on there. So if I have a negative and a positive here, and then I have another positive just kind of hanging out to the side, and let's change this to a different color because it would have to be also a different compound. Okay. So I have two positives and a negative. A single replacement is when I have one of those positives switching to another partner. So my green positive charge would want to hook up with the yellow negative. And then my red positive charge would be by itself. This is an example of single replacement. If we were to use actual chemicals, we could say green was K, because K has a positive 1 charge, and HCl, and then we would have our K and chlorine together, plus hydrogen. Hydrogen would be by itself. So this would be an example of our single replacement, where we switched our partners at the end. All right, last but not least is going to be our double replacement. Double replacement is fairly similar to our single replacement. The only thing is, instead of having only one element or compound switch its partner, you will have two or both elements or compounds switching their partners. And again, remember, partners is kind of referencing the charges. So let's go ahead and have our example from the last one. Let's just go ahead and add an extra element here so we can all kind of look at this. I have a positive and negative and a positive and negative. My positives have switched their partners, so that means I once again have green and yellow together. But I also will now have, red won't be by itself, it will be another tan cube right here. So tan and red would be together and green and yellow would be together at the end. This would be our example of a double replacement. So these are our four different types of chemical reactions: synthesis, decomposition, single replacement, and double replacement. So there should be an attachment on Google Classroom talking about your classification of chemical reactions. It should look something like this. This is your main assignment for today, is completing this right here. There's only 10 questions on today's assignment. And then you should have a secondary worksheet. I only need complete 17 problems. So on this worksheet, you only need to complete 17 of these problems. And let's go over this. When I have synthesis, decomposition, single replacement, and double replacement, I don't mind you typing out the word, but if you want to abbreviate it, S for synthesis, D for decomposition, SR for single replacement, and DR for double replacement, you are free to do that. So if we look at our first problem, there are two things coming together to form one singular compound. So that is an example of synthesis. Question 3, one singular compound being broken down into its basic parts. That would be an example of decomposition. It's being broken apart. Same thing with number 4, one singular compound that's being broken down. That's another example of decomposition. If I have number 10, this is an example of double replacement because PB combines with S in the end, and then hydrogen combines with NO3. And so both have found a new partner, so that would be representative of double replacement. Number 7 or number 8, if you look at these, one singular element replaces another. And so in 7, aluminum replaces hydrogen, and hydrogen gets kicked out to the curb. Number 8, chlorine takes the place of bromine, and bromine gets kicked out to the curb. So both of these would be examples of your single replacement. Last but not least, you want to make sure that you balance these. So let's go ahead. Let's look at number 2. Magnesium is red. Oxygen is yellow. So I have magnesium and oxygen, which combine together to form magnesium oxide. And I would compare, do both sides match? Red and red are good, so we need to focus on our yellow. And again, we can't just throw atoms in there, we have to just add another molecule. So, now that I've added another molecule, I have 2 on either side, and reds, I need to kind of put another one here. So I know that my balanced equation would be 2, 1, 2. So if you had any questions, please let me know. And then have a wonderful, wonderful day.